All right, ladies and gentlemen, good morning. So today we are going to kind of go back a bit to 7th grade and possibly 6th grade as well. Do a little refresher here on combining like terms and what like terms are. So eventually, pretty soon, within a week or so, we're going to be solving equations involving like terms. And it's going to be a little difficult for us to do that if we're not really exactly sure what like terms are and how we combine them. So we're going to take a little time to kind of go back to our 7th grade lessons on like terms. So the do now, which we haven't really seen yet at all this year, it says to circle the like terms. So I'm going to say, well, I've got an x term and I've got an x term. So the first thing we're going to remember about circling terms is we always circle them with their signs, and the sign is to the left. We're going to say, all right, well, I have a y term here, and I also have this y term here, negative 2y, and I've also got what are called constants. Okay, so a constant is a term that does not have a variable, right? It could be an integer, it could be a fraction, it could be a radical, but it's a term without a variable. So there's my like terms. It gets a little tougher with 2 and 3. So let's at least look, we don't need to look at both of them, let's look at 2. So I see a constant of 5. I've got this other constant of 9, and that's it. I have an a term in negative 3a. I've also got positive 6a. I've also got negative a, which is like saying negative 1a. I've got this b term, right? So I've got negative 4b. And then I've got that b squared term, which is not the same, which we'll talk about in a few minutes. And I've got negative 12b. And then that b squared term, that's going to be all on its own. So let's talk about what exactly like terms are, and then we can talk about how exactly we combine them. So let's talk about this, and then we'll come back to the other part, okay? Like terms have the same variable and same power, okay? So this should absolutely definitely be in your notes, underlined and highlighted. Same variable and same power. Now, we don't see when we solve equations, at least not yet, maybe towards the end of the year when we get to quadratics. But when we're solving equations over the next couple of weeks, we're not going to see anything with the powers yet. Everything is going to be to the first power. So we're primarily focusing on same variable, though we will see some different powers a little bit at the end of today's lesson. But that's the main takeaway here. And we'll come back. So what are we going to do? Well, we're going to circle the terms of the expression, which is what I just did with the do now. Number 2 is kind of an optional step. Okay, this is a lesson from when I used to teach 7th grade many years ago, and I used to I would group it at first, doing it in 8th grade after you've seen it. I generally don't do that, so I'll do that for the first couple examples, and then we'll kind of bypass it. Combine the like terms by adding the coefficients, and again, you need to have the signs of the terms to have the coefficient correct, and you rewrite it starting with a term raised to the highest power. That's called standard form. That's not something we're going to see too much, because again, we're dealing primarily with powers of 1, but going forward, that's going to be something that we get to a little bit later in the year with different powers. And just a little note here, that is, if there is no coefficients, there is always a coefficient. The coefficient is either 1 or negative 1. So if you see x, for example, that's really 1x, so 5x plus 6x, 5x plus x would be 6x. And if you see negative x, or in this case negative y, that the coefficient is negative 1, and you would add 4 to negative 1 to give us a coefficient of 3. All right, so let's take a look at something very basic like this, right? So 5x plus 8 plus 3x plus 7. So I have like terms of 5x and positive 3x. Now we know that if the lead term does not have a sign written, that it's positive. And I've also got these like terms of positive 8 and positive 7. So again, guys, for the first example, maybe the first two, I will regroup them together. 5x plus 3x. Positive 8, positive 7. So 5x plus 3x is 8x, and 8 plus 7 is 15. Let's do the same for the second one. I've got this x term 7x and negative 9x. Again, really important that we group the terms with their signs attached to the coefficients. And then I've also got my constants here, negative 8 and positive 5. So if I wanted to regroup them, and again, this is not necessary, I have 7x minus 9x, I have negative 8 plus 5. 7x minus 9x is really 7x plus negative 9x. That's really the way that we're approaching this. And negative 8 plus 5 is negative 3. So when we approach the addition of the like terms, and we'll get to this with the next one, we're really just adding the coefficients, right? I'm adding positive 7 and I'm adding negative 9, and that's what's giving you the coefficient of negative 2. So now we should be able to do this without all that regrouping. So I'm going to say, okay, negative 5x and positive 8x adds up to positive 3x. And positive 3y and negative 9y add up to negative 6y. Again, I'm just adding the coefficients. I'm not doing anything with the powers or anything else. All right, for number 4, I see 2x and I see x. And again, if there's no coefficient written, we know the coefficient is 1. That gives me 3x. I see my negative 5y and my positive 3y. Negative 5y plus positive 3y is negative 2y. And finally, I see my constants, which are positive 3 plus negative 7, which gives a sum of negative 4. All right, so now I did say we were going to do at least one that's got some powers to it. Because again, right, this is kind of preparing for the future. We will see this again. When we add and subtract polynomials a little bit later in the year, we will get to this. So an x term is not the same as an x squared term, right? We said we had to have same variables and same powers. So I'm going to say, I see this negative 2x squared term, and I see its like term, which is positive 8x squared. So I add the negative 2 and the positive 8, and that gives me 6x squared. All right? Make sure we're not doing anything with exponents, right? We're not adding, subtracting. Nothing changes with our exponents. The only time you would do that is if there's multiplication or division, which we won't see for quite a while. All right, and with the next part, we have positive 3x and negative 5x, which add up to negative 2x. All right, and for the last one, we have x terms, y terms, and constants. So I've got 5x and negative 5x. 5x plus negative 5x is 0 for several reasons. 1, because the sum of their coefficients is 0. 2, because they're opposites, and we know the sum of any two opposites is 0. We're not going to write 0x, right? 0x would be a little bit silly, right? What is 0x? Well, it's going to be 0, regardless of the value for x. 0x is 0, so we never would write a coefficient of 0. Next, I'm going to move on to my y terms. I've got positive 3y and negative 3y, which also gives me 0. And again, I'm not going to write 0y. I'm just going to leave it as is. Now, if I had constants that were opposites, I would say my solution would be 0. I can't just leave my answer blank. But in this case, we don't. Positive 30 plus negative 17 is positive 13, and that's it. That's my answer. Okay, guys, so this is going to be your homework. So what I want you to do is I want you to write out the question. I want you to circle the like terms. If you want to regroup them, you can. Obviously, I regrouped the first two, but not the rest, so it's not mandatory. But I do want you to write out the question. Just giving me an answer of number 1 is 9a plus 10 doesn't really help me know what exactly you're doing, how you're grouping, things like that. So make sure you write out the problem. You can group the terms how you want. You can color code it. You can use different shapes. You can simply just circle them all, whatever works for you, and give me the final answer underneath. Any questions or concerns, we talk about it on Google Classroom.